What is going on, guys? Welcome to your ninth physics lecture, and in this lecture I want to talk to you guys about something called vector subtraction. Now, vector subtraction is a lot like vector addition, which we learned in the last tutorial, but instead of taking two forces and adding them together to make a bigger force, what this does is you have two forces acting in opposite directions, so you end up with a force that's kind of an average between them. So let me go ahead and give you guys an example, and hopefully you understood vector addition, and if you did, this should be pretty easy to catch on. So say that you have an airplane and it is traveling north at a speed of 100 miles per hour. So that's your vector, which is going to be symbolized in an up arrow. And the other force is, say that you have a wind. It's going to be a windy day, and this wind is blowing southeast at 25 miles per hour. Now, of course, southeast, if you're thinking north is up and south is down, is going to be to the right and down. So you have two forces acting in opposite directions, even though they aren't completely opposite, they're different from each other. So how do you find the combined force or the end result of these vectors? Well, what you need to do, just like in vector addition, you first draw the first force or one of the forces, which is north or up at 100 miles per hour. So let's go ahead and do that and draw an arrow north, and I'm just going to write 100, and I won't put the units right there, it doesn't really matter, at 100 miles per hour. So this would symbolize your plane right here. So now what you have to do is you need to draw this other vector southeast at 25 miles per hour, but you just don't draw it anywhere. You need to draw it head to tail. The tail of this one needs to be drawn on the head of this one. So you go ahead and take the tail and you draw it right there. So this force would be 25 miles per hour in the southeast direction. Now remember, whenever you are actually drawing these on graph paper, it's kind of hard to draw them to scale when I'm just drawing on my computer screen. But whenever you're drawing them on graph paper, make sure that this right here is 4 times the length of this, or else you're going to get skewed results. So whenever you do that, the last thing you need to do, the last step in this problem, is you need to draw your last vector from the tail of the first one to the head of the last one. So let's go ahead and do that right now. I'll draw mine as a dotted line. And this right here, actually probably shouldn't draw an arrow. I'll just name this vector x is your end result. So even though I can't measure this, let me just go ahead and guesstimate and say this is 80 miles per hour, and that is, northeast or somewhere in that direction. So this is your end result. You take the end vector and you just measure the length of it, and also you can figure out whatever direction it is by where it's pointing. So again, like I said, this is vector subtraction, and whenever you do this, you end up with your end result somewhere between your biggest vector and the vector acting in an opposite direction towards it. So this is a way that you can calculate the path of a plane, and actually planes need to take wind into account before they make their flights, and if you're a pilot, then you would need to figure all this stuff out, or the air traffic controller. I'm not really sure who figures all that stuff out, but someone does. So hopefully through this crazy example you understand vector addition and vector subtraction, and we're ready to move on to the next topic, which are Newton's laws of motion. It's going to be exciting, so I'll see you guys then.